Kevin asked me to address two questions. One is, how do we build a stairway of talent, and how do we make the sector more attractive, beg your pardon, to postgraduates? I put the brackets around postgraduates because I'm going to talk about graduates as well as postgraduates. So that's great that Kevin asked me to speak on those two topics, because that's what we do at the UK Electronic Skills Foundation. Man, it's going forward. Sorry. That's what we do. We connect students at university with employers, and we try and encourage more young people to get into electronics. That's a photo of one of the first events that we ever did, the foundation ever did, with some of the stakeholders involved. We are, since I was last in front of an audience, we did celebrate our 10th anniversary. We were hoping for big celebrations, but that's COVID got in the way, so there you go. That's our 10th anniversary celebration. Thank you very much. Thank you very much. Those of you that read Electronics Weekly, does anyone read Electronics Weekly? Last week they did an 8-page supplement for our 10th anniversary, so there was some material there. It's trying to give a flavour of the things that we've done and the things that we are doing. So what do we do? We've got a programme, and it starts on the left. You can't have more engineers in the sector if people aren't aware of and interested in electronics. They need to know more about it. So we need a campaign to get more people aware of electronics. Then when interested, when they're doing A-levels or Scottish, I realise Paul's here and Ronan, Scottish hires and advanced hires, we need that 16 to 18-year-old group, we need to give them opportunities to get into it. Then when at university, we need to connect them with employers and make sure that when our graduates graduate, not only do they have the technical knowledge and understanding, they've got some work experience in the sector, and they've got some other skills, broader life skills as well. So that's what we do, as well as some skills consultancy work as well. Why? Why do we exist? Why is there a problem? Well, the demand for graduates is massive. Electronics is a horizontal enabling sector, working into many verticals, and a lot of those verticals are really expanding. So there's an increase in demand for electronics, and I should say we take a very broad definition of what electronics is, which includes embedded systems, touches on cyber, touches on software as well. So a very broad definition, increasing demand. However, if you look at and this is going to show you a graph of some data from UCAS of the number of UK students starting 3 sorts of engineering degrees: mechanical engineering, civil engineering, and electrical and electronic engineering. And that's a graph from about a decade and a half. As you can see, last year, twice as many UK students started mechanical engineering degrees as opposed to our subject. And the data shows that it's great. There's a lot of initiatives to increase the number of people doing engineering, and people are studying. 24,000 started degrees, but the numbers doing our subject are plateaued. Why is that? Well, there's a whole lot of reasons. I'm going to show you a slide from 2007, a photo from 2007. It's the first time Steve Jobs stood up with an iPhone, which 2007 is 14 years ago. Before that, there were no smartphones in the world. And you think it's now the world's biggest category of product. So a new product was invented, the smartphone, and it completely dominates. When you think about the technology that's involved in a smartphone, not just a microprocessor, hard drive, memory chip, you've got a touchscreen display, you've got a voice-activated AI agent, you have GPS, you have wireless, MEMS. There's so much technology. It uses fast Fourier transforms. There's a whole lot of technology, but it's all hidden away. It's all compact. So that's why it's successful, and as I say, the most successful product in the history of humanity. However, it's all hidden away, and therefore people can't see it. Why electronics? So we come up with a definition of what electronic. When people say what electronics is, that's what we say. It's using technology creatively to make innovative products to help solve problems and make people's lives better. And there's a very powerful video that we sometimes show when I talk to young audiences. It's called Emma's Story. It's about a graphic designer with Parkinson's disease, so she has a tremor. Spoiler, there's a technological solution to help her draw again. It's a very moving video, and it works very well at trying to get young people into the subject. In terms of, I said a campaign, we call our campaign Turn On to Electronics. It's aligned with the Royal Academy's campaign about trying to change the perception about engineering. Our message is, technology is the future. Young people understand technology. Technology depends on electronics. Electronics is a career you can do as a young person in this country, solving problems, making innovative projects, earning good money, and you can do it all in the UK. And part of our campaign is highlighting people from a diverse background that are successful in the sector, written in language that young people and their parents can understand. And that's an example of some of the collateral produced, using Eve, Patrick and Michaela, who are graduates from our undergraduate scheme, and as you can see, very diverse looking young people, so hopefully we can appeal to more people. It's not just academic routes into the sector. We need to think about vocational routes, because not everyone is academic, and a lot of the sector, oh man, it's going, I beg your pardon, it went quickly. So on the top left there, we worked with a consortium of local companies in Lancaster. They created an organisation called Tech Lancaster, got some funding from the government to do a boot camp, 12-week course, some of it online, some of it face-to-face, on the basics of electronic manufacturing. Really successful course, 85 people participated, 60 did the IPC certification at the end, and 17 of those who weren't involved in the sector are now working for companies in the Lancaster area, and a similar number have progressed within their company. That's a really great example, and there's another call for funding for boot camps, hopefully coming out later in the year, and it'd be great to scale that model up on a larger scale. We just submitted a bid. Yesterday was the closing day for bids, part of the Driving Electric Revolution programme through Innovate UK for an initiative to try and promote power electronics, drives and motors. And we've partnered with Aston University to come up with an initiative next Easter to try and encourage more people to think about power electronics. Also coming to the horizon, and this applies to a whole lot of companies, are T-levels. For those that don't know and didn't look at the slide that I flicked on inadvertently a minute ago, T-levels are a vocational equivalent to A-levels for 16 to 19-year-olds. The engineering ones are going to be introduced next year in 2022, and part of that is a 45-day, I keep going, sorry, I don't know why, it must, 45-day work experience, which is a great opportunity to connect with young people as a precursor to some sort of apprenticeship. And with electronics, we've got apprenticeships at level 3, level 4, level 6 now, and at level 7. So there are apprenticeship routes into the sector that people can follow. If people are following a traditional degree route into the sector, there is hope, despite the numbers that I showed you before, and hope is based on the numbers of people doing the enabling A-levels. This is data from the Joint Centre for Qualifications, Council for Qualifications, that brings together all the examining boards, and this shows that maths is by far and away the most popular A-level. Last year, almost 98,000 people did maths, 40,000 did physics, so that's great if you say those two subjects are the enablers for our sector. If you look at the ones that are increasing, then computing, which is now a more rigorous A-level than ICT, is really increasing as well. Almost 14,000 people did A-level computing last year. So that's a way that there is some hope on the horizon, that there is a market out there if only we can make our sector more attractive and get people more involved. One of the projects that we do is to focus on teachers. And the reason for focusing on teachers is the fact that teachers reach a whole lot of pupils. They have to teach the curriculum, and the curriculum in physics and computing does include some electronics and electrical principles. If we can give them the resources, and these are 2 project kits that we've given them. It's not a project kit to make, it's a teaching tool to help them deliver the curriculum and engage the kids, and give the teachers some training, then they'll be able to deliver the curriculum in a better way. We also recognise that these people going to universities want to see what it's like at universities, and these are some slides of of where we've been to university and have held face-to-face sessions, residential courses for people at universities. Very successful way of getting people into it. Clearly this year we weren't able to do that, so what we had to do was a virtual course sponsored by onsemi in partnership with Aston and Royal Holloway, and that was really good. We did answer 3 questions. What is electronics? What's it like to study electronics at university? And what's it like to work in the sector? And in terms of the latter one, we had support from Sahini from onsemi, along with one of their interns called Altheria, and they were great. They shared their experiences virtually, did a video, and then did some Q&A. And that was really inspiring to girls, to the session. That links to what else can we do. I don't believe in role models. 1,000 young people were asked about could they name a role model in engineering. 27% of them couldn't name one individual as a role model. However, I like real models. They're people like Etheria, and some people I'll show you next slide. These are young graduates. They're the people that 16 and 17-year-olds can relate to. I'm too old. I'll look around the room and say, we are too old. We're all too old to inspire young people. They don't relate to us, but they can relate to someone who's at university or recently left university. Sorry, Ronan, that wasn't intended as any observation about an ageist remark, I should say. So we need more recent graduates to tell their story, to share their experiences. We've done it with a number of people and a number of different settings. And they're great. They're the best advocates, because if you're 16 or 17 doing your A-level of maths and physics, you want to see that someone who looks like you, who sounds like you, who's interested in the same things as you, is happy and successful at university and in their career. And that's something we can do. The second thing we need to do is give people a hands-on activity. We found this kit from Rapid. It's relatively cheap. It's based on an Arduino. There's no soldering involved. It's got a number of sensors which are listed on the back of the packaging. We created this initiative. We created some videos, some how-to videos, starting from open the box, load the IDE, and start doing the experiments. Along with some, now you've done the experiments, what else can you do? Along with a guide that explained the theory and gave people more of an introduction. And we call that Insight into Electronics. 850 people signed up to it within weeks this summer. So we've sent out the resources, and we hope to scale that up. So I think in terms of what we can do as a sector, we can promote the sector better to encourage more young people. We can show that there are successful and happy careers for them. They can show that there's people like them involved in the sector, and we can give them an insight into what electronics is through hands-on projects, whilst giving teachers resources to deliver the A-level curriculum in a better way. In terms of graduates, there's a couple of things that I would like to mention. One is an initiative through the Office for Students for postgraduates. So recognising in terms of data science and AI, then one way of getting more people into the sector is to take people who haven't got a first degree in the subject, but they've got an interest, and give them a postgraduate course in that. Part of that is looking for projects and work placements, and Coventry University and others are in the consortium, and that's a really good initiative. The other way is through our scheme, and we work with, and this is undergraduate scheme, we work with 26 universities right across the UK, and we connect students who are studying with employers. It's a really successful scheme in that we've had over 600 scholarships awarded, and of those that are graduated, 91% are working in the sector, which is really great testimony to the capabilities of the young people, as well as the fact that they've found companies, and here's a list of some of the companies that they work with, in order that they can get involved in the sector. And I will stop at that. And I apologise for the randomness of my presentation, which seems to have a life of its own. I do apologise for that.